Good morning everyone. I am Tanushree from Civil Engineering branch, and today we will discuss about the maximum stress and minimum stress occur in the column section due to the eccentric loading. So as I told you in the previous class, the maximum stress value we can calculate by adding the two stresses, that is the direct stress with the bending stress, that is the sigma 0 plus sigma b. The sigma 0 value is P by A and sigma b value is your M by Z. And by deriving this equation in terms of eccentricity, we can find out the sigma max value as P by A into 1 plus 6E divided by B, where P is the force, A is the area, E is the eccentricity, and B is the width of the section. Similarly, for the minimum stress value, that is sigma minimum, is equal to direct stress minus bending stress, that is sigma 0 minus sigma b. So sigma 0 is equal to P by A and sigma b is equal to M by Z. And in terms of E and B, we can put the formula as P by A multiplied by 1 minus 6E divided by B, where sigma 0 is equal to direct stress, sigma b is equal to bending stress, M is the moment, and E is the eccentricity. So moment you can calculate by multiplying force into eccentricity, as we know that moment is equal to force into distance. So here force is your P and distance is your E. After that, Z is equal to section modulus, that is you can calculate by I by Y, where I is the moment of inertia and Y is the distance of extreme fiber from the CG of the column. So now you can see the variations of the diagram of maximum and minimum resultant stress here. So whenever the loading system is coincide with the longitudinal axis of the column, then only direct stress is developed in the column section. So here the diagram is plotted as this type. So it is a case of rectangular type section which is positive in nature, and the right side of the edge is act as sigma max value and the left side of the edge is act as sigma minimum value, which is same. That is, in case of this type of loading system, that is the case of axial loading system, the sigma minimum value is equal to sigma maximum value. Then the second figure, it is represent that the loading system of eccentricity. So if eccentricity loading, that means if the loading is not coincide with the longitudinal axis, then here at the right side of the edge of the column provided with sigma maximum value, that is the combination of bending stress and direct stress, and the left side of the section denoted as sigma minimum value, that is the difference between direct stress and bending stress, and it is positive in nature. So you can see this figure. Then after that, due to some case, this kind of figure also made due to the eccentricity, and if the section is the compound type section, that is the T section or I section, where the combination of flange and wave is there, in this type of section, this kind of diagram is provided. where the right side of the section is provided as sigma max value and left side of the section is provided with sigma minimum value. So the sigma max value is equal to the positive type and sigma minimum value is provided with negative type. So now we can solve a numerical based on the stresses distribution system in case of column. So the question is, a rectangular strut is 150 mm width and 120 mm thick. It carries a load of 180 kN at an eccentricity of 10 mm in a plane bisecting the thickness. Find the maximum and minimum intensity of stress in the section. So here you can see what are the data givens. So it is a case of rectangular type of strut where the B is given as 150 mm, that is the width of the section, and next one is your depth of the section, that is 120 mm, and the loading system is given as 180 kN, which is a type of eccentric loading. Hence the eccentricity is given as 10 mm. So now B is given, D is given and load is given. So now we can convert the loading system, that is 180 kN into Newton. So we have to multiply 1000 here. After that eccentricity is given as 10 mm. So we can find out the area of the column section, that is B into D, as it is a rectangular section. So B into T is equal to 150 into 120 is equal to 18,000 mm square. So now we have the value of eccentricity, the value of area and the loading system also. So we can find out the sigma max and sigma minimum value by this formula. So sigma max is equal to P by A into 1 plus 6E divided by B. So P is equal to 18 into 10 to the power 4 divided by area, which is 18 into 10 to the power 3 multiplied by 1 plus 6 into 10 divided by width of the section is given as 150. Hence, we got the sigma max value as 14 Newton per mm square, which is equal to 14 megapascal. Similarly, to calculate the minimum intensity of the stress in the section, we have to put the formula of sigma minimum is equal to P by A into 1 minus 6E divided by B, where P is equal to 18 into 10 to the power 4 divided by area is equal to 18 into 10 to the power 3 multiplied by 1 minus 6 into 10, which is the value of eccentricity, divided by 150, which is the value of width of the section. Hence the value of sigma minimum is equal to 6 Newton per mm square, which is equal to 6 MPa. And now we have to draw the stress distribution in the column. So you can see this is your elevation part of the column section, where you can provide the loading system, which is a case of eccentric loading, which is 180 kN, and the distance between longitudinal axis to the load is small e, that is 10 mm, and below this elevation section we have to draw the plan of the section. So here we can provide the B value and D value of the column section. Hence we know that the B value of the column section 150 and D value of the column section is 120. Hence the stress distribution of the column section is provided with this. So as we know that the right side of the edge is given as the sigma max value and left side of the edge is given as sigma minimum value. So sigma max value we got as 14 MPa and sigma minimum value we got as 6 MPa. So hence we can draw the value of stress distribution for the column section. So this is all about your stress distribution or intensity of the stress in case of column section. So today this much. Thank you.